Hello friends, last time we saw the general equation of line to be converted into various forms, which were slope-intercept form and normal form. Also we saw the problems pertaining to the shape. So today we are going to see the topic of point of intersection of two lines. So today's topic is point of intersection of two lines. Further to which we will see the condition for the concurrency of three lines as well. So before going to the condition for concurrency of three lines, we shall see the topic of point of intersection of two lines. Let's say we have equation of two lines as a1x plus b1y plus c1 equal to 0. In the second equation of line B, a2x plus b2y plus c2 equal to 0. So in the first equation of the line, we see that the coefficient of x is a1, coefficient of y is b1, and the constant term is c1. While in the second equation of line, we see the coefficient of x as a2, coefficient of y as b2, and the constant term as c2. So let's say these are the two equations of the line, and we are required to find the point of intersection of these two lines. So in the earlier standard, we had seen the linear equation in two variables, wherein we had seen a method known as cross multiplication method to find the common points or the solution of those two linear equations. We shall make the use of cross multiplication method in finding the point of intersection of the given two lines as well. So by cross multiplication method, I can say that x upon b1 into c2 minus b2 into c1, b1 c2 minus b2 c1. So as we used to do in cross multiplication method, that for finding the denominator of variable x, we used to hide the coefficients of x in the respective two equations, and we shall see the coefficients of y and constant term by cross multiplying the coefficient of y of the first equation to the constant term of the second equation, and coefficient of y of the second equation to the constant term of first equation. So we shall make the use of same method over here as well, by keeping the x as the numerator, and for denominator I will hide the coefficients of x, which is a1 and a2 for both the equation of the line, and I'll multiply the coefficient of y in the first equation with the constant term, that is c2, in the second equation, and then I'll multiply the coefficient of y in the second term, which is b2, to the constant term in the first equation, which is c1, and I'll subtract b1 c2 and I'll subtract b2 c1 from b1 c2. So we shall get x upon b1 c2 minus b2 into c1 is equal to, now I'll replicate the same method for the y. I'll take y at the numerator upon, I'll hide the coefficients of y and then multiply a1 with c2, which is a1 over here represents the coefficient of x in equation number 1 and constant term c2 of the equation number 2, and I'll multiply the coefficient of x in the second equation, which is a2, with the constant term in the first equation, which is c1. So I'll get c1 a2 minus c2 a1, c1 a2 minus c2 a1, and the third side of the equation would be 1 upon, now this time I'll hide the constant terms of the two equations, which is C1 and C2, and I'll multiply A1 with B2, A1 with B2 and A2 with B1. So the equation further becomes 1 upon A1 B2 minus A2 B1. So by cross multiplication method, for the given two equation of the line A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 equal to 0, I can write it as x upon B1 C2 minus B2 C1 equal to y upon C1 A2 minus C2 A1 is equal to 1 upon A1 B2 minus A2 B1. Now let's say x dash and y dash are the coordinates or the point of intersection of these two lines. Then I can say that x dash y dash would be equal to, over here I'll multiply x upon b1 c2, I'll equate x upon b1 c2 minus b2 c1 with the last term, that is 1 upon a1 b2 minus a2 b1. So I'll get x, let me first equate a1 b2, which will result to x equal to b1 c2 minus b2 c1 whole upon a1 b2 minus a2 b1. So x gives me this value, where x is the point of intersection of the two lines and x over there is the x coordinate of the point of intersection. Similarly, if I further equate to the next two sides of the equation, I can write y upon c1 a2 minus c2 a1 is equal to 1 upon a1 b2 minus a2 b1. So this can further be written as y is equal to c1 a2 minus c2 a1 upon a1 b2 minus a2 b1. So from this I'll get the value of the y coordinate of the point of intersection. Hence, if a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 are the two lines, then the point of intersection of these two lines are x and y, where the coordinates x and y can be written as x comma y is equal to the value of x coordinate is b1 c2 minus c1 b2 upon a1 b2 minus a2 b1, and the value of y coordinate is c1 a2 minus c2 a1 upon a1 b2 minus a2 b1. So with the help of the coefficients of x, y and constant terms, we can find out the point of intersection of the two lines provided to us. So based upon this theory, we are going to see now certain examples so that we have certain clarity about how we can apply this formula. Let us see some examples. Find the coordinates of the point of intersection of the lines 2x minus y plus 3 equal to 0 and x plus 2y minus 4 equal to 0. So friends, now we are provided two equations of the line 2x minus y plus 3 equal to 0 and x plus 2y minus 4 equal to 0. We are going to find the point of intersection of these two lines. So we already know that, let's say x and y, x comma y are the point of intersection, then the value of x is b1 c2 minus c1 b2 upon a1 b2 minus a2 b1, and the value of y coordinate is c1 a2 minus c2 a1 upon a1 b2 minus a2 b1. Now comparing the provided two equation of the line with that of the one which we had used in the theory, we say that b1 is the coefficient of y of the first equation of the line and c2 is the constant term of the second equation of the line, and c1 is the constant term of the first equation of the line, and b2 is the coefficient of y of the second equation of the line. Similarly, A1 is the coefficient of x of the first equation of the line. B2, we had already seen that it is the coefficient of y of the second equation of the line. Right. A2 is the coefficient of x of the second equation of the line. We had seen about B1. Now I think we had covered B1, C2, C1, B2, A1, B2, A2, B1. Similarly, C1, A2, C2, A1, A1, B2 and A2, B1 represents the respective coefficients of x and y as well as constant term of the two equation of the line. So comparing the two equation of the line, which is A1x, comparing these two equation with A1x plus B1y plus C equal to 0 and A2x plus B2y plus C2, let me put C2 equal to 0. We say that A1 is equal to 2, B1 is equal to -1 and C1 is equal to 3. However, A2 is equal to 1, B2 is equal to 2 and C2 is equal to -4. So if I compare A1x plus B1y plus C1 equal to 0 with 2x minus y plus 3 equal to 0, I can say that in place of A1 I can write 2, in place of B1 I can write as -1 and in place of C1 I can write 3. A1 equal to 2, B1 equal to -1 and C1 equal to 3. Similarly, if I compare the second equation, that is A2x plus B2y plus C2 equal to 0 with x plus 2y minus 4 equal to 0, I can say that the value of A2 is equal to 1, the value of B2 is equal to 2 and the value of C2 is equal to -4. A2 equal to 1, B2 equal to 2 and C2 equal to -4. So substituting the value of A1, B1, C1 and A2, B2, C2 in our point of intersection, we can write that, let's say x, y are the point of intersection, then the value of the same is equal to B1 over here is -1, C2 over here is -4, minus of C1, B2. C1 we have as 3 and B2 we have as 2. C1 is 3 and B2 as 2 upon A1 B2 minus A2 B1. So A1 B2 is 2 into 2, 2 into 2 minus A2 B1. A2 is 1 and B1 is -1. So A2 I'll have 1 and B1 as minus. Similarly, I can write C1 A2 minus C2 A1. C1 A2. So C1 over here is 3 and A2 over here is 1 minus of C2 A1. C2 over here is -4 and A1 over here is 2. So 2 whole upon we will have same as A1 B2, that is 2 into 2 minus of A2 B1, that is 1 minus of 1. So further we shall get -4 into 1, -4 into -1 is equal to 4, minus 3 into 2 is 6, whole upon 2 into 2 is 4, 1 into -1 is -1. So -1 and on the outer side we have minus as well. So this becomes minus minus plus. Similarly 3 into 1 is 3, minus -4 into 2 gives me 8 and -8, and since outside is minus, the sign becomes plus and the number is 8. So 3 plus 8 upon 4 plus 1. So the point of intersection becomes 4 minus 6 is -2 upon 5 and 3 plus 8, that is 11 upon 5. So these are the -2 upon 5 comma 11 by 5 are the point of intersection of the two lines. 2x minus y plus 3 equal to 0 and x plus 2y minus 4 equal to 0 as provided to us in the question. Let us solve one more example pertaining to the point of intersection of the line. Find the value of m for which the lines mx plus 2m plus 3 of y plus m plus 6 is equal to 0, and the second line is 2m plus 1 of x plus m minus 1 of y plus m minus 9 is equal to 0 intersect at a point on y-axis. Find the value of m for which the lines mx plus 2m plus 3 of y plus m plus 6 equal to 0 and 2m plus 1 of x plus m minus 1 of y plus m minus 9 equal to 0 intersect at a point on y-axis. So by cross multiplication we can see that x upon 2m plus 3 multiplied by m minus 9, which over here depicts b1 c2 minus of m minus 1 into m plus 6 is equal to y upon 2m plus 1, where 2m plus 1 is a2, into m plus 6, which is c1, minus of m, which is a1, into c2, which is m minus 9, is equal to 1 upon m into m minus 1, which is a1 b2, minus of 2m plus 3 into 2m plus 1. So by comparing the solving further, we'll get this implies x upon 2m into m is 2m square, 2m into 9 is minus 18m, and 3 into m is plus 3m. So that becomes minus 15m, and 3 into minus 9 is 27. Minus of, let me put x in the middle, m into m is m square, m is 6m, 6m minus m, which is equal to plus 5m, minus 6 is equal to y upon 2m into m is 2m square plus 12m plus m, which is equal to 13m plus 6 minus of, we'll get n square minus 9m is equal to 1 upon, we'll get n square minus m minus of 4m square plus 6m and plus 2m, so plus 8m plus 3. So this further results us into x whole upon 2m square minus m square is equal to n square minus 15m minus of 5m, so which results into minus of 20m. Minus 27 minus minus becomes plus 6. So minus 27 plus 6 will fetch me minus 21 whole upon is equal to y upon 2m square minus m square will give me n square, 3m plus 9m, sorry 13m plus 9m will give me 22m plus 6 is equal to 1 upon n square minus 4n square will give me minus of 3m square, minus m minus 8m will give me minus of 9m minus 3. Now the point of intersection hence becomes x is equal to n square minus 20m minus 21 upon minus of 3m square minus 9m minus 3, and y is equal to, I can write m square plus 22m plus 6 upon minus of 3m square minus 9m minus 3. So now we are provided that these are the 2 points of intersection of the given two line, but the point of intersection lies on the y-axis. Now since the point lies on y-axis, let me write, since the point of intersection lies on y-axis, the x coordinate becomes 0. So x coordinate of the point of intersection becomes 0. That means x equal to 0, but x value is, this implies n square minus 20m minus 21 whole upon minus of 3m square minus 9m minus 3 is equal to 0. So by multiplying both the side by minus 3m square minus 9m plus 1, I'll get n square minus 20m minus 21 is equal to 0, which can further be factorized into n square minus 21m plus m minus 21 is equal to 0, and we shall have two factors, of which one is m minus 21 and the other one is m plus 1 is equal to 0. So this implies either m is equal to 21 or m is equal to minus 1. So we shall get two values of m. First is m equal to 21 and m equal to minus 1 for the provided two equations of the line. Friends, we are going to see in the next lecture the point of concurrency of three lines.